In this video, we'll be covering the Intro to Calculus, so the basics of calculus, which include, for this video at least, it's going to be specific for the derivatives of any functions or values that we have. Okay, so over here, let's take the example of a car that's really speeding down a highway. Okay, so it's accelerating, and the speed, that means that the speed is changing every second or so. Okay, so let's say you look down at your speedometer and you see that you're going at around 90 miles per hour, but now let's say you just froze the entire motion, right? So everything is just frozen, and in that frozen motion, you want to know what's the speed of this car over here at the smallest change in time. So the smallest change in time means the change in time that is the closest to zero, and the change in distance that is the closest to zero. Okay, and we know that our formula for speed is given by s is equal to d over t. Okay, so this is your formula for speed, and if d is the closest amount to zero and t is also the closest amount to zero, how do you find s, right? Like, that would be really hard. And in order to answer that question, we use calculus. Okay, so now moving on to derivatives. This is a really big word, but it means a pretty simple thing. So over here, you have the phrase instantaneous rate of change. So all this means is basically just the derivative. So like I said over here, you have your car. The instantaneous rate of change would just be the speed. So let's say you're trying to find the instantaneous speed, right? That's also a form of rate of change. It's just the rate of change of distance, so the rate of how the distance is changing at a rate of time, right? So speed can be called instantaneous speed, and now let's say you want to find the instantaneous speed at a value of t is approaching zero, you would use derivatives and you can find your instantaneous speed. So that's all that instantaneous rate of change means, and understanding that makes calculus, or at least the basics of it, much easier. Okay, so now let's cover how do you really solve that. Okay, so over here you have the function f of x is equal to x squared. Like I said before, the derivatives is finding the rate of change, right? And if you recall your algebra or whenever you learn this, you know that the slope, right, or basically the rate of change again, so the slope is just the rate of change. You have m is equal to delta y, so delta, in case you don't know, is just the rate of change of something, so it's basically just yf, so the final f, minus y initial, right? So you have delta y over delta x, so it would just be xf over x initial, okay? And like I said before, the rate of change means that it's changing by something, right? So over here, when you're trying to say that in terms of f of x, and you're trying to say that in terms of differentials, what you can say is, so this is how you would write the differential, d f of x. So all that the d means is just the smallest rate of change. So don't get confused by it or scared. It's not that complicated if you understand what it means. So it's just saying basically just the smallest rate of change. So d f of x by dx is equal to, so your final f of x, so that your final, after the change happened, your final f of x would be, let's say we call it f of x plus h, meaning that your f of x increased by h. So that h is like the smallest number, so the number that's closest to zero though. So you have to remember that so you don't get confused. So you have f of x plus h divided by x plus h minus x. And to help you, you can keep this in brackets because that makes more sense. So x plus h, again, h is the smallest rate of change, so the smallest change that happened, and you're just minusing, you're just subtracting the original x. So over here, what you can say, all you need to do is substitute it. Oh, I forgot you have to say over here minus f of x. Okay, so now you just have to substitute for your f of x, right? And this is, some people might get a little confused over here, but all you're saying is x plus h whole square. And you're saying whole square because x plus h is in the brackets over here, so you just add the square over there because the function is x squared. So x plus h whole square minus x squared, right, because that's your original function. And then the denominator is pretty straightforward, so you're just saying that. Nothing too interesting happening over there, right? Okay, so now let's focus on this a little bit more. So now you just expand this using the square of sums. So you can just say x squared plus 2xh plus h squared minus x squared. And you just say x plus h minus x, right? So over here you see that x squared minus x squared obviously equals to 0, and then x minus x is also equal to 0, so the x terms over here and the x squared and x squared are gone. So you just get 2xh plus h squared divided by h. So over here you can see that there is a common factor, which would be h. So over here, let's say you take, so that's an x, by the way, if that's a little confusing. Don't confuse that for a multiplication sign. So you have h times 2x plus h, right, because you're taking the common factor out. And you just have h over here. And then you can just cross these out, and you get 2, so let's move that down. So you get 2x plus h. But if you remember, like I said before, h is the closest number to 0. So if we're trying to find the derivative of x squared, well, all we have to do is assume this is 0, right? Because like this is like 0.0000 and so on, like 0.1 or something. You know, it's basically negligible at that point. So if you say h is approaching 0, you can say that basically the answer is 2x. So therefore, the derivative of the function f of x is equal to 2x. Okay, and another way this can be written, so it's just like a format, honestly. All you have to say is, remember how we said df of x by dx is equal to 2x, basically? So instead of that, you can also say, so you can also say f prime x is equal to df of x. So instead of writing df of x, if you don't want to, or even if you have a question that doesn't write it like this and they just say like, oh, what's like f prime x, that's basically just 2x, right? And you know that, just in case you forgot, f of x is equal to x squared, right? So x squared, and so f prime x is equal to 2x. So now you know why a derivative works the way it does, what it means, and how to solve for one. And if you notice the pattern over here, right, so you have x squared, right? So you know what, let's use this, like, let's just make the whole thing in terms of variables. So let's just treat, I don't know, like f of x is equal to x to the power of n. And we don't know what n is yet, and let's just say we're going to be defining it soon, but let's just assume that f of x is equal to x to the power of n, okay? And then you're trying to find the derivative of x. So over here, you can see that the 2 kind of drop down to multiply x, right? So kind of like a coefficient. So this became, so f prime x became nx, but to the power of what? So over here you can see that 2 dropped down, but then over here in the exponent, what happened is it just became 2 minus 1. So over here it just became n minus 1. So if you want to prove this further, what you can do is you can try, so over here we went over all the formulas and we said the original one was in order to find the derivative of f of x, the function f of x, you can say f of x plus h minus f of x divided by x plus h minus x. So if you want to further prove the derivatives for all these exponent, like, you know, let's say f of x is equal to x cubed, like you can substitute that and do that, you will get 3x squared, and you will get 3x squared. And a simpler formula for this would be that f prime x is equal to nx to the power of n minus 1. So yeah, so let's try f of x is equal to x cubed real quick so that we can prove that that is true. So let's say you have f of x is equal to x cubed now. And we just discussed that the formula is that f prime x is equal to nx, okay, let's move that, nx to the power of n minus 1. So in this case, we can see that this over here is your n, so n is equal to 3. So that means that f prime x is equal to, so you drop the 3 down, right? So n is over here, so 3, and then x, and then 3 minus 1 over here, which would basically give us 3x squared. Okay? So yeah, that's it for the derivatives and the basic intro to calculus. I hope this video helped. Thank you for listening.